Hello, my name is Aldrich Coleman, and I am part of Challenge 2016, and I'm going to be explaining what it means for a real value function to be one-to-one. Real value functions is a function whose values are all real numbers, and real numbers are rational numbers, integers, fractions, and irrational numbers. Real numbers can also be written as a symbol. This means all real numbers. Okay. So one-to-one. For one-to-one, every element in the range is going to be only assigned to one single domain. And yeah, it's often written as one-to-one. So keep that in mind. So basically, for a function to be one-to-one, it must pass the vertical and horizontal line test. The vertical line test is a visual way to find out if a curve graph is a function. So the way to find out, or the way to perform a visual or vertical line test is to draw a vertical line across a graph, and if it crosses more than once, it is not one-to-one. And the horizontal line test is also a visual way to find out if a curved graph is a function. So you draw a line horizontally across a graph, and if it crosses more than once, it is not one-to-one. So these coincide. So basically, if a graph passes the vertical line test but doesn't pass the horizontal line test, or vice versa, it's still not going to be one-to-one because it has to pass both tests. So if a function passes both vertical and horizontal line tests, then it is one-to-one. So for example, if we get an x squared graph, which looks like this is the x-axis, the y-axis. So an x squared graph will look like a curve going up. So for example, here, this passes the vertical line test. So we drew a vertical line down, and it did not cross more than once. So it passes the vertical line test. But since we draw a vertical or horizontal line, and it does cross more than twice, or more than once, I'm sorry, one here and one here, twice, then it does not pass the horizontal line test. Therefore, it is not one-to-one. So now, we have an xy squared graph. So an xy squared graph would look like this, almost like a yx squared graph, but it's kind of sideways. So now the xy squared graph does pass the horizontal line test since it only crosses at one spot and not more, but it does fail the vertical line test because it crosses twice. So this is also not one-to-one. Now I'm going to give you an example of a graph that does pass both horizontal line and vertical line tests and is one-to-one. So I'm just going to give you a basic x equals y graph. Okay. Sorry. So it crosses at the 0 here. And so if we draw a horizontal line, it only crosses once. And if we draw a vertical line, it only crosses once. Therefore, it passes both horizontal and vertical line tests. So this is a one-to-one. Okay, so now we have the problem with a tangent, because a tangent is kind of complex when it comes to this concept. Okay, for tangent, tangent is kind of special. Tangent is not one-to-one when it's in the whole domain, so it's kind of hard to explain, so I'll draw it out. So the way a tangent graph looks, it's going to look like this. It's going to start with curves going up. So this is what a tangent graph looks like, and then it does not cross here, so therefore it is all of these are passing the vertical line test, but it is not passing the horizontal line test. So this is actually not a one-to-one, a tangent on its own, where the domain goes to infinity and the range goes to infinity is not one-to-one. But when we have a different kind of tangent and we change its domain, that's when it gets kind of special. So when we change the range of the domain to only fit in one of the drawings for the tangent, it's just going to look like this. And so we change the range, so now it does pass both the horizontal and vertical line test. So this is also one-to-one. But the only way we were able to make this tangent one-to-one is by changing the range. Okay, so but since it is now one-to-one for the tangent, we're able to find its inverse. And now that we can find the inverse, which is arctan is equal to the inverse of tangent. So arctan is actually written as arctan is equal to tangent -1 y, or x, yeah, x. Sorry. So arctan is written as tan -1 x is equal to y or fx. So the way that this would actually be graphed, since it's the inverse, would look like this. Oh shoot, my bad. So it would go down, curve up. And this does pass both the horizontal and vertical line test. So one-to-one, meaning it can have an inverse, but we already know that the inverse of an inverse is the original function, which would be tan x. Thank you.